Welcome to my channel dedicated to the geomorphology and geology. Today I am going to talk about sandspits. Sandspits are a particular coastal formation created by the transport along the coast of debris from sea currents or even lake currents that move parallel along the same coast. Now let me show you some example of a sandspit. We go to the Azov Sea, that is located between Russia and Ukraine. Here we have the Crimea Peninsula. Here it is possible to see some formation like this one that starting from the coastline entered the sea creating a bar, which generally tend to bend toward the coast, forming a kind of hook. Another example, it's here. We have the sandbar that enter the sea and then tend to bend toward the coast, forming a hook. Here we have two hooks, like this one, that bend toward the coastline. Another feature of sandspits is that where they leave the main coast, often they form a salt marsh behind them, as it's possible to see here or here and here. The formation of salt marsh area is possible because behind the spit the currents have less energy than in the open sea, so debris can sediment forming the marsh. The size of a sandspit can sometimes be considerable. For example, here we have one almost 16 km long. Here in the Black Sea, we have a spit that is more than 14 kilometers long. Or here this one is more or less more than 16 kilometers long. Here it is possible to see the salt marsh as well as here. And here we have the spit that tend to bend toward the coastline. Before explaining in detail how a sandspit is formed, let's see where a current along the coast comes from, referring to this picture. We have a longshore current when the current that hit the beach is not perpendicular to the shoreline. So there will be a longshore component that runs along the coast and consequently a longshore drift. As wave break onto the shore at an oblique angle. The swash pushes the sediment up the beach and the backwash returns it to the sea at a right angle to the coast due to the force of gravity following the line of maximum slope. Over time, this zigzag movement carry large amounts of sediment along the beach, in this case from the left to the right. Well, now we know what a longshore current and drift are, we can discover how a sandspit is formed, referring to this picture. Generally, to have a sandspit, it is necessary to have a change in the direction of the coastline as here. Once the material moves to the right of the coastline direction changing, the previous longshore reef keeps on acting more or less following the coastline direction from where it comes. In this way, the debris are projected into sea, where they can sediment forming the spit. Behind the sand spit, there will be an area where current have less energy than in open sea, so debris can sediment forming a salt marsh or a freshwater marsh if we are in a lake. Referring to this other picture, after entering the open sea, the sand spit tend to bend to the coastline, and that, according to this picture found in the internet, it could depend on secondary most dominant wind here. To me, there could be even another reason of bending. In fact, when the longshore drift leaves the beach on the right and enters the sea, behind it there is no more a solid mass as ground, sand or rock that avoid the move of the sand acting as a barrier. But there is only seawater, so the spit tend to bend in the same direction of the prevailing wind, and it keep on dropping sediments, forming a new land, until this new land is able to do not allow the bending, and so the spit will be able to move again toward the open sea and bending again and so on, forming other bending shapes. Now we return to the Azov Sea to observe some of the concepts before explained. In this sand spit, it's possible to see that the direction of the current is not perpendicular to the coastline. So there is a component of that current that is parallel to the coast, forming the longshore currents that create the longshore drifts. Near the end of the spit, it's possible to see how the direction of the wave of the current tends to bend, giving meaning to the spit bending in that area. The different color of the water represent how sediments carried along the spit are projected in the open sea. Opening the color changing is not related to the pollution, of course. Referring always to the same sand spit, it's possible to highlight some other particularities. In fact, it's possible to see here many curved lines that represent the ancient line coast and consequently the evolution of the sediments behind the sand spit that formed the existing sand marsh over hundreds or thousands of years. In this other sandspit, the ancient line coast represents the evolution of the sandspit bending at this end. Of course, the upper coastline are older than the lower one. Let me show now some other example of sandspit around the world. Here we are in Africa, and we go here in Gabon, where it's possible to find a very long spit, this one, where the town of Port-Gentil has been built, and Port-Gentil is the second largest town of Gabon after Libreville. The spit has been formed mainly thanks to the debris carried by the river Ogooué. Here we have the river Ogooué. That is the most important river of Gabon. And the debris at the end of the river has been taken by the longshore drift, and then they are formed, and they are forming the sandspit. It is possible to observe how the river has influenced the structure of the sandspit. For example, here it's possible to see the cut made by the river. And here we have the ancient line coastline of the sandspit, as well here and here. Another feature we can see is that here on the north shore, on the north side of the river, we have the sandspit structure, and in the south side of the river it's possible to find a plain that has been made thanks to the deposition of the sediment carried by the river Ogooué. A second example is present in Portugal, near Lisbon. Lisbon is the capital of the Portugal. Here there is Lisbon. This is the Tagus River estuary. On the south, it's possible to find this pit that has been built on the Sado River estuary. Here there is the city of Setúbal. As a last example, we return in Africa, and exactly in Angola, where a part of Luanda, the capital, here we have Luanda, a part has been built on this pit. And on the south, it's possible to find another pit that started here, then it bended, keep on going along the coast in a parallel way to the coast. However, sandspits are quite common coastal formation that can be found almost everywhere in the world. So I let you to discover many other examples. Thanks for watching.